Hi there. We are here to present Terrorist Tracker, an artificial intelligence criminal tracking system. Terrorist Tracker uses computer vision to assist law enforcement in tracking down wanted terrorists, burglars, fugitives, and other suspects. Terrorist Tracker utilizes a network of camera feeds across the country from airports, shopping malls, government buildings, businesses, and other public areas to monitor and search for wanted criminals and suspicious activity. Once a criminal has been identified, Terrorist Tracker uses AI to track the criminal through remote control of PTZ cameras by following them and zooming into their exact location. In addition, Terrorist Tracker can save governments and businesses money as hiring human resources can be expensive. Studies show only after 20 minutes, security guard attention spans drop significantly. I'd like to share a clip from James Bond to illustrate my next point.
Train's leaving. Do I get on the train?
Don't get on the train, I'm not sure he's on it. Give us a minute.
Do I get on the train?
Bond,
What?
get on the train.
As seen in the clip, James Bond partner Q could only look at so many screens at one time, leaving some blind spots unmonitored. During our investigations, we found that weapon datasets with humans wielding them were hard to come by. Thus, we decided to study the effectiveness of synthetic datasets for training models and see how they would compare to hand-annotated models. We created 3 models, one using our own hand-annotated images only, one using synthetic images extracted from video games, and lastly, a hybrid of both. We then measured the effectiveness based on their mean accuracy precision at different thresholds. Terrorist Tracker works by initially finding all the human bounding boxes in the frame quickly using Tiny YOLO. This step is to narrow down the search and speed up processing by eliminating redundant parts of the image. A small buffer is then added around the bounding box to ensure no parts of the human is missing. Next, a CNN model is used to find where the face bounding box is located in the search window. Once the face has been found, we extract a FaceNet 128 dimension feature vector from the subject's face. The feature vector is then matched up with the database encodings, and if a certain threshold has been exceeded, then the best match is projected to be the suspect. Terrorist Tracker will also determine if the suspect is carrying any weapons in the search window, using our pre-trained YOLO models mentioned earlier. Once a suspect has been detected, Terrorist Tracker in real time follows the suspect by remote controlling the PTZ camera. Terrorist Tracker does this by keeping the middle of the face box near the middle of the x-axis and the top 1/3 of the y-axis. If the face box doesn't move for several frames, the Terrorist Tracker assumes the suspect has stopped moving and zooms into the suspect to get a clearer shot. If the suspect is no longer in camera view, Terrorist Tracker automatically zooms back out and continues its search again. Now let's see a demonstration of Terrorist Tracker tracking and zooming into a suspect. Had Q used Terrorist Tracker, it would have identified the fugitive a lot quicker, thereby allowing James Bond to apprehend Raul Silva before he escaped. Here are the results of each trained model detecting persons. As seen by the bold numbers in blue, the hand-annotated model did the best at 50 and 60% thresholds, whereas the hybrid model fared better at higher thresholds. The synthetic model alone fared the worst of the three. When it comes to detecting guns, the hybrid model won handily in each threshold category, with the hand model coming in second and the synthetic model coming in a distant third. The overall scores had the hybrid model winning at every threshold, showing that synthetic data can aid in training models better than hand-annotated models alone. Synthetic models alone don't fare as well, but do much better than zero. In conclusion, Terrorist Tracker can be a cost-effective system in apprehending criminals through the use of AI, apprehending them sooner before they can commit their next crime and be brought to justice. Synthetic datasets have also proven to be very useful, and the great thing is we have an abundance of video games to extract the synthetic data from. This allows getting datasets of scenarios which otherwise might be impractical. For example, getting footage of real wars or battles, getting footage on Mars might not be practical, but could be simulated through synthetic data. The concept of using AI for object tracking can be applied to almost any application, such as tracking license plates, hands-free selfie drones, searching for new or endangered animals, or anything else that you can dream of. Thanks for watching. We'll answer any questions you have, and we'll end with the reference page.